Ladies and gentlemen, boys and girls, thank you all very much for coming. It's 1700 here in the UK. It's 1900 in Moscow, and it's 9 a.m. on the West Coast. So good afternoon, good evening, and good morning. My name is Martin, and over the next 40 minutes or so, I shall walk you through monitoring and management of diffusion. I will introduce the concepts. I'll show you it working. As many of you will know by now, this webinar is part of a series, each tackling a concept that you're going to encounter in the development of a diffusion-based solution. This webinar is going to differ a little as its target audience, rather than developers, the management and DevOps teams that are responsible for putting and keeping the lights on of a diffusion-based solution. Please put your questions to me via the Q&A feature, and I will answer them throughout the presentation. If I don't know an answer, I'll have a good think about it, and I will get back to you with one. So let's set the agenda. Firstly, not to be overlooked, we're going to look at the diffusion logging mechanism. And then next, we're going to examine the face of the product, the diffusion console. Then moving on to JMX, which is as old as the hills. And more recently, we'll look at Prometheus. Along the way, we're going to see the more diffusion specific features, the session metrics and the topic metrics. Finally, as a bonus, we shall detail briefly into the more advanced features of mission control, specifically the Java flight recordings. Firstly, to logs. Everybody's got them, and it's important to do them right. The diffusion server logging mechanism uses the simple logging facade for Java, or SLF4J. So it's performant for us, and importantly, it is pluggable for you. Out of the box, diffusion includes log4j2, so you can use other SLF4J implementers like logback or chronicle. While push can't support those for production use, your mileage may vary. Logging configuration is held in etc logs.xml and mostly in etc log4j2.xml. The former includes configuration for a legacy deprecated logging mechanism and includes comments saying so, whereas the latter is where all the good stuff is. Log4j2 is a product in its own right, and it could be the subject of a complete webinar, but here are the basics of the configuration as it comes with diffusion. Starting with the loggers, there are two of them, console and file. Both do as the name suggests. Console writes to the standard output of the server parent process, usually a shell of some sort, whereas file writes to files. Looking further into the configuration of each, in the appenders configuration, see how the console appender takes only a pattern layout, and we'll see what this means a little bit later on. Next down, the rolling random access file, the file appender, that takes a lot more configuration, mostly relating to buffer flushing, file names, rotation policies, and rotation naming patterns. In this case, the log file is rotated when the process is started, when the day has passed, or when it has exceeded 250 megs. Finally, we can see that it will allow no more than 200 log files, 20 log files. The properties section is a key value store, but the pattern property is interesting as that is used by both the out-of-the-box appenders to govern the format of each log entry. Here's an example of one of those lines and how the format string relates to it, starting with %date. This is an ISO format date and time string. It's in 24-hour clocks with milliseconds. Next is the log level entry, log entry level. In order of urgency, this can be trace, debug, info, warn, error, and fatal. Out of the box, diffusion logs nothing less than info level. So debug and trace are not logged by default, but we'll see shortly how you can change that. %thread is the name of the Java thread. In this case, it's the main thread. The marker is next. These are small, but ever so useful. Each discrete diffusion log message of level info and higher, so not debug or trace, has a unique marker, which makes them easy to search for both in the file and also on Google. And it also opens them to statistical analysis. Percent message is next, which here is recording the maximum message size. And finally, the logger, which is broadly, but not exactly the same as the Java class that logged it. Some of you may have noticed that the out-of-the-box pattern includes the principal and the session ID for the log entry. And this is an example of a log entry where the principal Bob and the session ID for Bob are present and therefore logged. You can see that it's logging a session state change from connected to awaiting reconnection. So this session temporarily lost its connection. We can see that it's also a debug level message, and therefore it lacks a marker. By default, the logging level is info, so this entry would never be seen. Now, change the logging level to debug, and the log grows far larger, so we risk losing the signal in the noise. So if we only want this log entry just for user Bob, so Bob is experiencing more than an expected number of disconnections, we can add this to the configuration. This will elevate the client impl class to debug for log messages that match this regex and where the principal is Bob. This will have a performance cost, so use it judiciously, but do not discount the value of the results of this either. If we need to elevate all logging for a single user, we can use this, which is included in the comments of the out-of-the-box configuration. This elevates all logging for user Bob to debug, leaving it to info for everybody else. A simplified view of the server log is also available in the console, where we can press the play button to follow the log entries as they happen. And the metrics tab shows you a histogram of the log entries classified by their marker, and we'll see the same data available throughout other media. So moving on to the console, we all know about the console, which we can usefully think of as a graphical shell about the most frequently used diffusion features. We can use it to browse, measure, create, delete, and edit topics using the Topics tab. We can browse, measure, and close sessions using the Sessions tab. But we can also create, edit, and delete authentication roles and principals using the Authentication and Security tabs. If there's one feature that stands out as being not present here, is the messaging feature. But the real management powers come when using the topic, session, and log metrics. Starting with the topic metrics, we can identify fractions of the topic tree using a topic selector. And in this case, we select the foreign exchange topic branch. Notice that we can optionally expose the results to Prometheus as well. And once it's defined, we see real-time stats about the FX branch, so we can see where the data is spent and consumed by subscribers, creating value. And as much as possible, you want to ensure those numbers match up. You want to know that you're spending your data where subscribers care about it, creating the most value. The session metrics are calculated via server-side analysis on the set of sessions, which, as we know, can be very large. As we can see here, we have 100 or so sessions, either anonymous or belonging to principals Ted or Jack, who both hold the trader role. To discover how many trader sessions I have and how much data I'm spending on them, I create a session metric collector that filters roles that have the trader role. There we go. When we click on the metrics tab, we can see the live results, that about 2/3 of the audience are traders, and that since the metric collector was defined, we've pushed 3 going on 4,000 messages to them. If you keep your eyes on the output bytes column, we can see that these results are live. We find the log metrics in the logs tab, which shows us the count of each unique log entry marker, ordered by severity and priority. We can see that this server has an unsympathetic configuration for the number of CPUs. Permission allowing a reduced view of the log file is also available through the console, which we control with these familiar audio style buttons. We can even show all the log fields and press play to see the events as they happen. Now, Diffusion runs in the Java virtual machine. We all know this, and it makes good use of the JMX components that come with that. Java management extensions have been part of the JVM since version 5 in 2004, so I guess that JME was already taken by then. Its scope is pretty broad, but at its heart, JMX gathers a set of managed beans and exposes them to outside interaction, and for brevity, they're known as mbeans. Each bean focuses on a component of the product, say a diffusion connector or a multiplexer. Each mbean has a name that safely namespaces it. So the set of mbeans often includes beans from many providers, including those from the underlying JVM, as in this case. Mbeans have a set of properties which can be read-only or read-write. And mbeans also expose a set of operations analogous to remote method calls. So JMX is useful for more than passive monitoring. And each mbean exposes a descriptor of its purpose. And indeed, the diffusion mbeans go above and beyond in this category. Right, demo time. So let's take a quick aside. We'll have a look at what we've got here. What I have here, I have a diffusion server up and running. It's playing some FX data, and I have an audience subscribing to that. So we can actually see what's going on. We have a real system that's really doing work. And what we have here is JDK mission control. There we go, which is connected to it. And what we are connected to is the mbean server. We're connected to the set of mbeans inside our diffusion server. And as I mentioned earlier, these mbeans are namespaced. We can see there's a couple of namespaces here with familiar names. The com push technology.diffusion namespace is ours. Java.lang is all about the Java runtime. And interestingly, log4j2 makes an appearance down here as well. We'll have a look into that shortly. So the first thing I'm going to show you is the log metrics. So these are the set of, this is essentially a histogram. It's a count of the number of times these log entries have happened inside, have been logged to the diffusion server log. They're not ordered in any particular way. Let me go, push 231, there's 6 of those. So we'll see that the management information that we're looking at often is made available through, in this case, the console, or through JMX. And I know this is also made available through Prometheus as well. So by hook or by crook, this information will be made available to you. Log metrics on its own is interesting, but what's much more interesting is the metrics that you get to decide. So we have on this server a couple of session and topic metric collectors. Let's have a look at this. We discussed earlier the traders session metric collector, and we can see the values right here. We've got 67 trader connectors, trader sessions connected to this box, and that's the number of inbound bytes and outbound bytes. And we can, although we're grabbing this graphically here, JMX is open to coding. You can collect the information programmatically just as easily. So that's the traders metric collector. And let's have a look at the, we have 2 other metric collectors for the topics, one called branch A and branch B. Let's have a look to see what these actually mean. So I have this open. So we have some fairly big old data in here, but we don't know how big branch A and branch B are. They're larger than can be easily imagined. The FX branch, we're familiar with this. We don't need to dig into, but branch B is so large, it's actually been paginated. So imagining how much data that's going to consume is a problem. So we put in some metric collectors. We have a metric collector here for branch A that uses the familiar topic selector syntax. So this gathers metrics for every topic underneath branch A. We could use more sophisticated, more complex topic selectors here, but in this case, it's just a split path topic selector identifying branch A and everything underneath it. It's also been exported to Prometheus, as we can see here. And the information is available here. We can see the stats and they're live. Interestingly, we can see that branch B and branch A have 0 subscribers. So it has questionable value. Let's be brave and let's create a new one for FX. Completely unscripted, what could go wrong? What's it called? Was it called FX? Just FX, yeah. I'm going to export that to Prometheus. And the FX branch, look at the values for that. FX branch has got 100 subscribers. And those stats will update as the data is pushed into them. So we can start to understand the size of and shape of the topic tree. And we can see the same information. There we go. FX branch has just popped up there. And we can see the data rolling out through JMX just as well. Let's have a quick look at the Diffusion server itself, because there's a lot of information to be had inside there, especially if you're concerned with keeping the lights on. One of those things that you will be concerned about is the license expiration date, which we can see here is a very long way in the future. We can also see the license properties as well. See how long the server's been up and running, which is important. All the usual sort of stuff. More interestingly, we can drill into the operating system, find out how much physical memory we have, how many processors we have, how much real RAM we have to work with. And in fact, this is an interesting thing to be wary of. So available processors in this case is 12. I have 12 hardware cores to work with on a laptop. Amazing. And if I compare that number with the number of multiplexers that I have, a multiplexer in Diffusion, we can draw parallels between a multiplexer and the cylinder in an engine block. And it is the job of a multiplexer to deliver data to a slice of the total audience for that server. And the health of a multiplexer is reflects on the health of the server overall. So it's important that we get the right number of multiplexers. Let's see how many we have. That will be in the multiplexer manager. I have 6. So out of the box, Diffusion will play it safe and give you user only half the number of hardware threads as multiplexers. In a typical production deployment, you would be more aggressive. You'd use somewhere closer to 10 or maybe even 11. You don't want to use all of them because each multiplexer runs hot on the CPU that it's given. So you want to leave some headroom for the other threads to get their work done. But as much as possible, you want to eliminate the possibility that the Diffusion multiplexer threads will suffer thread contention. In this case, it's not going to. In fact, there's a lot more headroom we could actually make use of. Okay, so everything we've done so far is passive. Let's press a few buttons, flip a few levers, and see what happens. So if we go back to our Diffusion server, we can see that everything it's logging is at info level. But if I want to change that, I can find myself the logging component, make myself a bit of space. down here, this anonymous mbean, there's an attribute called info. We're going to change that to trace, all caps, and the result will be immediate. There we go. We can see immediately it has started logging to trace. So we can now get much more visibility into the functioning of the machine at the cost of much more output. Let's undo that. There we go. It's quite a common practice for solutions to use tools like New Relic and App Dynamics to consume these log files to populate their own databases. That's perfectly normal because then, of course, you get a great deal of visibility into the functioning and health of a machine over time. And as for a bonus, let's do one last thing. If in some circumstances, if the Diffusion support team are unable to give you an immediate answer, one of the things they may ask you to do is to get what's called a multiplexer dump. And this involves calling a notification, an operation on this object. We're just going to do that here. Let's call this operation. And there we go. So this has produced a report, and it's actually written the files to that particular directory. And we'll not go into the content of the files right now. They're all CSV. They're fairly easy to grok the shape of them. But we can see here that this is more than just consuming. We can actually manage the server. We can interact with it and tell it to do things that it wouldn't do for you through the Diffusion SDK. This is very much a management interface. Okay, well, I've covered everything I think I wanted to in the demo. Let's get back to the slides. So there are a few options when connecting to the JMX service of a Java-based product like Diffusion. We've already seen the local connector, where so long as your JMX client is running as the same user as your Diffusion server, you can see and connect to it without further need to authenticate. But for connecting remotely, Diffusion includes a connector server that authenticates connections against the Diffusion authentication and authorization system, and it controls access to the mbeans according to the permission of that principal. A principal needs the view server permission to read mbean properties and the control server permission to change a read-write permission. Intuitively, the control server permission lets you call any operation, though holding only view server, you can only call operations that have an impact of info. So you can only call operations where the results are nil. To enable the Diffusion connector server, we open the etc management.xml file, and we find the root management element, and we set the attribute enabled to true. We set the host to 0000, which will bind the connector server to all network interfaces on that machine. Or indeed, you could just nominate a specific one. The registry and connection ports are 1099 and 1100 only by convention. And then I've removed the key store element. Once this is done, you can connect to a remote Diffusion server with your JMX client. Here we're using mission control again. And that will get you connected to the remote server like this. And from there on, it's as though you're interacting with the process on your own machine. So JMX is demonstrably very potent, but it is also arguably very over-engineered. As they did with JMS, JDBC, and JPA, Sun specified an API rather than a solid implementation, which in this circumstance left the reference implementation as the default implementation. There are other issues with JMX, many of them. However, the one I'm focused on here is the wire protocol we use, as it needs 2 TCP ports instead of 1, and that makes it much harder to connect if there's a firewall in the way. On the upside, you can use it for more than just passive monitoring, and the surfacing of the facts and the operations inside mission control is intuitive, and we'll see more of this later on. Moving on, Prometheus, named for the Greek mythology's Titan who stole fire from mankind from the Olympians, is an event monitoring and alert product that's finding wide use in the industry. Prometheus polls its monitoring subjects over HTTP and builds an efficient time series database that can be used for basic reporting and alerting. Diffusion's monitoring endpoint is at http://host:/port/metrics as per convention. We take a look at the content you get there. It is very legible. At the head of the output is the state of the JVM, and you can see the help and type sections shown in blue here. They have a structure. They look like comments, but they have a structure. Most of these metrics are gauge types, which are numeric values which can both increase and decrease, whereas some are counters, and counters can only go up. Histogram and summary are the other two Prometheus data types. A little lower down, we can see the diffusion specific information. Here we find the diffusion log metrics replicated, the same ones we've seen in JMX and also in the console. We can see both of these via JMX and in the console, but as well as metrics relating to Diffusion server itself, Diffusion also replicates any session metrics and topic metrics you have defined. So you can record stats relating to the functioning of your own solution. And the Kafka adapter also exports to Prometheus. On its own, Prometheus has fairly limited visualization abilities, but it really comes into its own when it's combined with Grafana. Grafana will connect to other time series databases like InfluxDB and OpenTSDB, and even regular databases like MySQL, Postgres, or MS SQL Server. But it's widely used, and indeed, you may already be using it. So Java flight recordings, built into the JVM and Java Mission Control, is the Java Flight Recorder, which is a profiling and diagnostic feature that has extremely low overhead and is designed to be useful in highly loaded Java processes, such as the Diffusion server is often. It's a commercial feature if you're running on the Oracle sourced version 8 JDK, but was open sourced in OpenJDK 11. So you may need a license for production use depending upon your technology stack. To enable it in Diffusion, we find and uncomment this line in the startup script where it says enable JFR. Once you have a recording, you can analyze them inside Mission Control. Here's an example of a recording taken during a performance test where it has not performed as quickly as we need. At a glance, we can see the 3 gauges of heap memory, CPU use, and GC pause times. They're all acceptable. The CPU use chart plateaus at 30%, which is interesting, as ideally we'd like to see far more CPU use, indicating more work being done and more value being delivered. The memory tab shows us this sawtooth pattern of a healthy garbage collector, and that the overall use is well within limits. Moving over to the System tab, we can see that there are 24 hardware threads available in this machine, which makes us wonder if we're not using them all efficiently. So next, we'll move over to the Threads tab, where we count only 4 multiplexer threads, with all of the load being taken by one of them, multiplexer number 1. So there are 2 problems here. The work is not distributed evenly across the multiplexer threads, and even if it were, there is more processing power available here than is needed for this test. We're just scratching the surface of this tool. It's well worth the investment if you depend on any Java-based product which must deliver on time, not just Diffusion. And now I'm just going to pause for questions, see what we've got. Okay, I've got one question from Joe. What if the Diffusion server creates more than 20 log files? Right, well, it will delete the oldest ones. I think along the way, it will compress them. So, and it will compress them asynchronously as well. It won't pause a whole thread. So it will, and text files do compress beautifully, as we know, but they still have, once compressed, they still take up space, and space, no matter how cheap, does still have a cost. So the default configuration is it'll fill up 20 log files, and then it'll start deleting the oldest ones. So if you want to persist them longer than that, then that's a good opportunity to intervene with either your own logging configuration and either persist more files or do other things with it, or put it into a log ingestion system like New Relic or App Dynamics. I got a question from Ellis. Good to have you back, Ellis. I want to change the logging configuration without restarting the server. JMX connectivity is tricky. What are my options? Indeed, JMX connectivity can be tricky. Getting those port numbers right is a fiddly thing. It would have been nice if there was a JMX transport, which was a little bit more modern, but alas, we don't have that. So your options are, well, the good news there is that log4j2, if configured to do so, will poll its configuration and will update its own operation if the configuration file is changed. So if you know what you're doing, and if you're deploying a proven configuration file, you don't want to deploy something with bad syntax, then you can change the configuration in live, and then change your logging configuration to put in something, for example, to figure out what's happening to poor old Bob with his connectivity. And the next one, back to Joe. Why shouldn't I use Java flight recordings in my production system all the time? It's a good question. So there's two sides to this answer. Firstly, if you're using the Oracle Java 8 stack, you may need a license to do that sort of thing. But more pragmatically and more practically, the Java flight recording is a very low cost, but not zero. It does consume a certain amount of disk space. It uses it as a circular buffer, so it's not infinite, but there is a small cost, and it's probably well within your budgets to do so. That is processing cost, but it's not zero. But for my money, I would, to be able to catch a production system and understand with complete certainty what was happening on that box up to the point that something exceptional happened, the cost of a Java flight recording looks to me like a very good investment. Okay, so I think we've no further questions. That's okay. So that's a wrap for today. Thank you all very much for coming. So today we covered Diffusion monitoring and management features, logging, JMX, Prometheus, both session and topic metrics, as well as log metrics, and Java mission control, which, as I mentioned, is useful for Diffusion, but everything else that's also based in Java. Be sure to subscribe to our YouTube channel. Click the bell to get the notification for when the next video is published. But for now, however, thank you all very much for coming. Be sure to come back for our next webinar. Cheers.